If you just watched the MPC multiplication video, you might be asking yourself, why did that work? Well, I'm going to give you two explanations. The first one is more of a visual explanation for us visual learners. So we had these two secret numbers. I'll call them A and B. Well, a visual way of thinking about what is A times B is it's the area of this rectangle. Where this side has length A and this side has length B. Okay, sure, we want to find the area of this rectangle. Well, we secret shared A and B. And when we secret shared it, what we did is we made three pieces which added up to A. I'll just give them names. So I'll call this one A1, this one A2, and this one A3. We did the same thing for B. We had three secret shares, B1, B2, and B3, that added up to B. If you remember on the table, they were distributed like this, where each of us could see 2, but not 3. So let's extend these lines. When we draw these lines, we get this key insight, which is there's another way that we can compute the area of this rectangle. We can just find the area of these 9 smaller rectangles and add them up. And that's exactly what we did. So from where I was sitting, I could see these 4 numbers. And I used these 4 numbers to calculate the area of this rectangle, and this rectangle. From where Blurta was sitting, she could see these 4 numbers, and she used them to compute the area of this rectangle, and this rectangle. And from where Nani was sitting, she could see these 4 numbers, which she used to compute the area of the remaining 3 rectangles. And that was indeed a secret sharing of the right answer. Because if you add the blue area to the green area to the red area, it adds up to the whole rectangle. Now, we also had this part about masking. Let me explain why that was necessary to roll those dice and mask things. So with the information that I had available, I could compute the area of these 4 rectangles. That's not enough to figure out the whole rectangle. But at the end, when Nani finished her calculation, she wrote a number on a sticky note and put it here on the table. With that information, which was these things, combined with the information that I could see already, that risks getting close to enough information that maybe I could figure it all out. And I could figure out the total value of the secret numbers A and B. And that's why we needed masking, to add a bunch of randomness to make sure that I couldn't figure out what A and B were. Okay, now I'll give you the second explanation of why that MPC multiplication protocol worked. This is more of a mathy explanation. So if you think back to the video, I was sitting here, and I could see these 4 numbers. So what I calculated was A1 times B1 plus A1 times B2 plus A2 times B1. Blurta was sitting here, and she could see these 4 numbers. She computed A2 times B2 plus A2 times B3 plus A3 times B2. Nani was sitting up here, and she could see these 4 numbers. She computed A3 times B3 plus A3 times B1 plus A1 times B3. This was a secret sharing, so ultimately it was correct to think about it as all of these things being added together. So what are all 9 of these terms added together? Well, because of distribution, that's the same thing as A1 plus A2 plus A3 times B1 plus B2 plus B3. If you worked this out and distributed all 9 of these terms, you would get every single one of these pieces. And this, if you recall from above, is the same thing as A. And this is the same thing as B. So what we found was A times B. And that's why it worked. Now, in the video, I talked about masking. So how do we do that masking? We rolled 3 dice. I'll call those dice rolls D1, D2, and D3. And they were here on the table, D1, D2, and D3. So why did adding these random numbers not mess up our computation? Well, let's look at what we did. I subtracted this one and added this one. Blarta subtracted this one and added this one. And Nani subtracted this one and added this one. And now we see why it wasn't a problem, because everything cancels out. I added D2, Blarta subtracted it. She added D3, Nani subtracted it. Nani added D1, I subtracted it. So everything cancels out and it doesn't affect the answer. And that's why masking didn't mess up our computation.